too little, sort of in a Goldilocks zone there. The growing system itself, in this sense, I'm using a hydroponic system so that all the nutrients and minerals are dissolved in water. Okay, so they're water-soluble salts, essentially, that transport the nitrogen, the potassium, the magnesium, and all the trace elements like chlorine, manganese, and all these other things. It's really quite interesting. If you look at the physiology of plants, there is not one organic thing that they absorb. It's all pure elements or inorganic elements. It's interesting. So this whole concept of organics kind of gets twisted on its head a little bit when you actually look at what the plants do and so on. They don't need soil. They grow very effectively in water if you give them the right nutrients, you balance the water, and you give them the right temperature.
On the blue and red shift that you mentioned to grow that's in a controlled environment.
Correct.
If you are outside and you want to do the same thing, what is the mechanism you can use to create bigger leaf than
you can't. I mean, the short answer is you really can't, because you're going to get sunlight. Now, sunlight has a full spectrum distribution. You can't control it. I suppose you could use some sort of filtering mechanism, but you'd have to make a big glass dome that has a big filtering mechanism that would filter out, one or the other. I don't think it's practical, but so supplemental lighting would do that.
The nutrient levels can affect that, because one kind of nutrient tends to, the potassium and nitrogen, I forget what, one goes more towards flowers and one goes more towards fruits.
Yes, and as a matter of fact, the balance between potassium, nitrogen, and so on is adjusted for what you're trying to produce. So tomatoes have a very different formula than, say, lettuce or basil, for example. Every plant kind of has its Goldilocks zone.
Thank you.
Other questions? Okay. So you also want to make sure you have enough dissolved oxygen, because think about essentially, right, because where do plants get oxygen? Well, they actually get oxygen from the water. Most of their oxygen comes from the water, not from the air. They'll get a little bit from the air, but most of it is coming through the roots, and so you have to make sure that your water has oxygen in it. And how do you do that? Well, very simply, you can bubble water into that, and that's usually sufficient, or you can drop water like in a stream, right? So streams will bubble water and they'll be highly oxygenated, which is what you want. In my case, I use an air stone, just like you would find in an aquarium, right? So you just bubble air into there. pH, of course, I measure. EC levels are the nutrient levels. They're measured by the total number of dissolved solids. That's the proxy for that. It gives you a pretty good idea of what your nutrient levels are, and of course, temperature. Output varies. In this case, it's a type of lettuce called Summer Crisp. In specific, this is a picture of a Muir lettuce, which is a really wonderful lettuce. If you've ever tried it, it's a terrific lettuce. It's sort of a little bit of a cross between a leaf lettuce and a little bit of a romaine. So it's got a little more bite to it, but it's a really terrific tasting lettuce. So the characteristics of the plants are the quantity, the quality in terms of size, weight, and color, and of course the market value, which I'll get to in just a sec. All right, so how did I go about this? Well, the first thing I had to do was pick a plant. In this case, I picked this Muir lettuce. I sow these seeds in 1 inch, what are called rock wool. It's kind of a spun wool, inorganic compound, right? That characteristic is it traps air in there, but it also absorbs water like a sponge. So the plants have, they're hydrated, the root zone's happy, right? And they're getting lots of oxygen, which is what they need, right? They're germinating in the dark for a couple of days, and then they have about 10 days of light. Yes?
That's not wasn't there something called rock wool used like 50 years ago to insulate houses that was like asbestos?
Yeah, this has nothing to do with that, but it is a derivative of that. But it's completely inert. You're not going to get asbestos poisoning from it. No.
Okay.
But yes, it's similar to that type of insulation. Yeah. You don't want to breathe it in because it can irritate the lining. I mean, like if you inhaled it. But once it gets wet, it's not. So if you're breaking big chunks of it, it will produce some dust, just like perlite will, that you can use. So you just don't want to breathe that stuff, but you wet it and then it's completely safe. It's actually considered a safe substance. It can actually go into landfills, and it's just inert. It sits there. It's essentially a rock material. It actually can help to aerate the soil. This rock wool was kind of brought to the world and to America through I think it was a Danish company, if I'm not mistaken, called Groden, and they've been around for decades. So at the first sign of true leaves, so they're small baby leaves. They're called cotyledons. These grow the first. They're like the first little solar collectors that come out, give the plant enough energy to produce the true leaves. And once you get to the true leaf stage, then they get transplanted into a larger system. Okay. The growing facility, that is my growing facility. It's actually, my garage is now becoming a greenhouse, instrumented to the hilt. This is, I brought water in there. This was just essentially a structure that had no insulation. It was just wood siding. And I went on kind of this massive tear to insulate it, measure all of that, so I have all that information. I've modeled it, done all sorts of crazy things with it. But it's a very energy efficient structure. The walls have about an R of 17.5. There are more things we can do. I haven't done the rafters yet, and of course this is a concrete slab. There are other things that could be done, but I'm kind of work with it as it is. We put some light, some windows in here. These windows didn't exist. This window here was kind of falling out, so repaired that and put in a new window there. Also, just recently put in a heat pump and to control the temperature both in summer and winter. It's one of the most energy efficient ways to do that. And it's in the Philadelphia area. Now this is the growing system that I built. It's a 4-tiered system. You can see these are the channels. Water is pumped to this side. It is on an incline. The water comes down here and then comes back into this recirculating system. So I can grow 288 plants in this system in a 4x8 or 32 square foot footprint. So it's very, very efficient from a production standpoint. I'm working with Philips to actually do some trialing with them. They've given me 30 horticultural level lights. These are the lights that are here that I'm just about to hook up and probably when I get back. There's a 40-gallon reservoir system, air stone, and all these components are food grade. The Philips lights are very, very high output but low energy. They're each 23 watts, but they're also optimized for this type of production that I'm doing. They actually gave me 3 different lights, so we're going to do a study within a study to look at the impacts of different wavelengths of light on the production of the quality and both the duration and so on. So that's kind of the study within the study. But my study is really interested, this particular study is really interested in what are the cost benefits of this growing system. And can it be, essentially, can I take this system and now go into a warehouse space and replicate it by 50 or 100 times, and would it be profitable? Yeah.
So are the lights only at the top, or are there lights at each level?
There are lights at each level. There's lights coming down here, lights coming down
here. And they're multi-frequent, you can change the color, or?
No, they're fixed, and they're blue shifted, but with some red mixed in. But they're very, very high quality horticultural lights. Any other questions? So I'm excited. I mean, I've become I feel like I'm a construction person because I've learned a lot about PVC piping and electrical and so on. It's things I didn't really know how to do anything a couple of years ago. I now know what I can do if I ever want to quit my job. Yes.
So since you brought it up,
yes.
Is this, I'm curious, is this project self-financed or is it a grant?
It's been mostly self-financed, but I did receive some support through the USDA. And because I'm doing trials with Philips, I'm going to be partnering with them on that part. So they did actually give me these lights, and they're not inexpensive. These lights are quite expensive. So, yeah. So it's a combination. Yeah. It's the love of learning.
Absolutely.
Okay. So here are the things that I mentioned before: light, daily light integral, oxygen, all this kind of stuff that and these are sort of optimal conditions for the plants. These are this is the references, again, how I'm setting the control conditions, right, to optimize the plant growth. It's all based on the literature. Input is being measured. I just learned there's a kind of really cool thing. I actually did get a grant to put solar on this. So I'm going to be putting some solar on it. Again, it's a partial, it's still coming out of my pocket. But I'll be putting solar on the roof of this system. But I did learn about a device called a SMAPI, and what it'll do is it'll actually measure all the energy being drawn in and out of this garage. So this was great because I'll be able to measure everything down to the kilowatt hour. Okay, so let's just take a look, and then the output measurements, plant quality and so on. All right, so here's some preliminary results. I'm just at the point of, I know some of my costs, but and I also know the face value of the lights and so on and so forth, but I will be comparing that to the actual results that I'll be getting shortly. So here's a total cost as a percentage of this, and I've made some assumptions. You can see labor costs are significant. Energy costs are significant, followed by the direct costs. So the seed and all that stuff is actually a small portion of that. Here's a blow up of the total direct costs, which include packaging, your pH up, pH down, nutrients, water, rock wool, and your little net pots. These are actually recycled, so this cost actually comes out, or reused, not recycled. I reuse these. So anyway, before I go on to that, any questions about either the direct costs or the
labor
total
costs,
operating costs?
are they your costs?
Excuse me?
The labor costs, are they your costs?
These are my costs or someone I pay to assist me. Yes.
Also, you included the lights too, the cost of the lights?
Yeah, lights are embedded in the energy. These include heating, cooling, and lighting.
But that's operating cost.
Yes.
I'm talking about the original cost
Capital
of the lights.
cost.
Capital costs I'll come to.
Okay.
I will get to that, yeah. Okay. Any other questions about that? These are operating, right? These are to turn the lights on, have them on about 16 hours a day, run them, grow the plants. Plants cycle from germination to maturity is about 6 weeks. They're about 4 weeks in the maturing system. They're about 2 weeks in the transplant or seedling stage. And that's cheaper. There's less energy involved in that. They don't need as much light when they're small. You need a certain amount of light, but not as much. But this is for the for the production part of it. Yes.
Have you considered using an alternative fuel source to power this?
Not at this point.
Okay.
Yeah. So.
Do you think that may be more cost effective, or?
Well, the alternative fuel source is going to be solar, right? So I've made the choice, the design choice from the very beginning, to make this an electric-based system, essentially. So all my costs, my heat pump's electric, my solar panels will be electric, and all the other devices are electric. So the coin of the realm here is kilowatt hours, essentially.
Understand.
And kilowatt hours.
Does the seedling part happen in the same space or a different space?
No, it's in a different space. And I do have those costs actually embedded here. They're much smaller proportion. They're probably about 15% of the total, because the light levels are smaller. Plus, you remember, it's all about space. You can put 100 seedlings in a space this big when they're tiny, and you don't need that much light. They can get all the light they need from one bulb as opposed to several bulbs. Okay, so here's market value. Now what I've done here is that I'm only growing in 3 levels for this purpose, so I have 216 plant sites. You can produce approximately, the number of plants per week is about a fourth of that, if you divide 1 month, right, into a month. And I've done it at different price levels. As you can see, as you go to green, you're getting a higher return. If I only sell the plants for $250, I'll give away something. I'm going to lose money, to be honest. It's hard to compete. I can compete effectively with organics, but I can't compete effectively with food that's grown under conventional conditions with pesticides, to be honest. But then again, we're lucky that we have a time when the market is becoming more aware of the hazards and the externalities associated with using all these vast amounts of pesticides, GMOs, and so on and so forth. Okay, so let's look at the gross profits at the different levels. As you can see, at 250, a plant, I'm losing 19% on my dollar there. I break even at about $3, and I'm profitable in this area. Now I have a small CSA because I need to do something with my plants. I'm also selling to a local cafe. So I'm charging them in this range of about, this was a guess months ago or a year ago. I thought maybe 4 would be right, but now I know that's definitely right. So somewhere between 350 and 4 is really where I need to be to make this a sustainable business, right? Questions?
How would this scale up in size?
Well, that's what I'm going to get to. Yeah, good question. Okay, so here are the capital costs for this small system. Remember that this garage greenhouse, right? So it has some light coming in, but mostly supplemental light, heating, cooling, and so on. These are the costs, to build the growing system, climate control, capital costs, HVAC, and so on. Building renovations, I had to do quite a bit, It's not, I own it, so it's fine, And some of it, I got some offsets from some of the energy efficiency components which came through. And solar power is, well, this is definitely a discounted rate, you know, with subsidies taken out. So I mean, but you know, it's probably close to about 20 grand to do this. But again, I had a structure that literally had a hole in the roof. Water was coming into the roof. It was just a, you know, a Dutch siding, no insulation, broken pavement and everything inside. I mean, I just hadn't gotten around to it. And I thought, well, this is as good a time as any, and I'll turn it into a research facility and production facility. Yeah.
So I was going to ask if you included the original capital cost of building the garage, but it clearly sounds like that may not be relevant. But it also doesn't sound like you included land cost.
No, I didn't include land. No, as a matter of fact. And so, you know, let's say the next step here would be, let's say I might just lease space. You know, I could lease 5,000 square feet, and really all you really need are those systems.
Right.
Yeah. So
That's it. And so, and you know, maybe that's the best way to go. All right, so let me so here's scaling to larger. Here's the current system, right? Here's the income that you would generate from just one of those 4x8 systems, 3 levels, 216 plants, right? You can net out about, over the annual basis, $4 a plant, you're netting a little under $3,000. But now take that system, scale it up 100 times, you only need about 4,000 square feet, right? But of growing space within, let's say you have a 10,000 foot warehouse because you need some other space. Assume 2 times the space needed. All right, you can have 21,600 plant sites. Now your income is 286,000 for that. But that's pretty good income to generate out of, you know, less than 10,000 square feet of space. Not bad.
Eric, $4 a plant is steep.
Agreed.
I mean,
Agreed.
we pay $6. I mean, almost $1 a head. I'm not talking about. I'm talking about romaine lettuce, for example.
Right.
Less than that.
And does it have pesticides?
You know,
Of course. You know, is it organic? You know, these are the choices we have to make. You know, luckily the market has moved to supporting these things. If you look at the true price of food, you know, we're paying under because we've been subsidizing this type of production for many, many years. So the question is, you know, when you buy organics and so on, it's more expensive. It's, you know, and that's just the fact of it. And you know, it's just the market. But I agree with you. Would I like it to be half that? I would love it to be half that. But you know, I can't compete with produce coming in from Costa Rica or other parts of South America. I look at the USDA pricing, you know, and frankly, working with chefs and so on, you have to get a chef that's really committed to this. Some say they're farm to table, but when the